What if we aimed the Hubble telescope at Earth? At first, the question seems simple enough. The Hubble Space Telescope is one of the most famous scientific instruments ever built. Launched into orbit in 1990, it has captured breathtaking images of galaxies, nebulae, and stars so far away, their light has traveled for millions of years just to reach us. But what if, instead of pointing it outward into the depths of space, we turned it around and aimed it at our own planet? Could we use it to see cities, forests, maybe even people? Would it reveal some hidden truth about Earth? Or is it just a waste of time? Let's start by looking at the problem. The Hubble was never designed to look at Earth. It sits about 547 kilometers above our surface in low Earth orbit, traveling around the planet at roughly 27,300 kilometers per hour. Its instruments are built for one specific purpose: gathering faint light from unimaginably distant objects. That means its optics and sensors are optimized to detect low levels of light over long exposure times. And here's the catch: Earth is extremely bright compared to deep space. The sunlight reflected off clouds, oceans, and land makes Earth's surface many orders of magnitude brighter than the faint galaxies Hubble was built to observe. In fact, if you were to point Hubble directly at Earth without adjusting anything, the sensors would likely saturate and overexpose immediately, producing nothing but a washed-out image. It's similar to how your eyes hurt if you suddenly walk out of a dark room into bright sunlight. Hubble was designed to see in the dark, but the problem doesn't end there. There's another, more subtle limitation: Hubble's field of view. The telescope can see a very narrow patch of sky, just 2.4 arc-minutes across. That's less than 1/100th the width of the full moon as seen from Earth. To put it another way, Hubble's field of view at its altitude would cover an area on the ground about the size of New York's Central Park. Not bad if you're trying to study a small area in detail. But useless if you want to see the big picture. And even if you aimed it carefully and avoided overexposure, Hubble's cameras would still face one more challenge: motion blur. At 547 kilometers up, moving at over 7 kilometers per second, Hubble completes one orbit every 97 minutes. Trying to track a specific location on Earth, while both Hubble and Earth are moving relative to each other, would cause the image to smear unless the telescope's tracking systems were adapted, which they were not built to do. That's why NASA and the European Space Agency, the organizations that operate Hubble, specifically prohibit using it to observe Earth. It's not just about capability, it's also about protecting the sensitive instruments from potential damage caused by bright reflected light. But that doesn't mean the idea is completely ridiculous. Let's agitate the question a little more by looking at what we have done. NASA and other agencies already use specialized satellites to monitor Earth. Instruments like Landsat, Terra, and Aqua are in orbit, purpose-built to collect data about our atmosphere, oceans, and land. Landsat, for example, has been continuously photographing Earth since 1972, with resolutions down to about 15 meters per pixel in its highest resolution bands. Commercial satellites can do even better. Some modern imaging satellites, like those operated by Maxar, can resolve details as small as 30 centimeters per pixel. That's good enough to see cars, boats, and even individual trees from orbit. A real-world case study shows just how far Earth imaging has come. During the 2010 Haiti earthquake, satellites provided rapid response high-resolution imagery to rescue teams on the ground, helping locate survivors and assess damage in real time. In 2020, when wildfires tore through Australia, satellites tracked the spread of the fires and smoke, providing invaluable data for emergency services. None of this required pointing Hubble at Earth. And that brings us to the solution. If you really wanted to study Earth in the kind of detail people dream about, the right answer isn't to misuse Hubble. It's to build or use technology designed for the task. Earth observation is its own field, with its own engineering challenges and requirements. High dynamic range sensors, wide fields of view, fast tracking systems. These are all things that Hubble simply wasn't built to do. But the spirit behind the question, using the best tools we have to look at our own world, is a good one. What would happen if we did more of that? We already have the ability to monitor everything from deforestation in the Amazon to shrinking glaciers in Greenland to the spread of cities into farmland. The real challenge isn't technology, it's will. The data exists, but are we paying attention? It's easy to look at stunning Hubble images of distant galaxies and forget that we're living on one of the most remarkable planets in the universe, and it's right under our feet. So no, we can't and shouldn't aim the Hubble Space Telescope at Earth, but we should keep asking questions about what's happening here. We should keep looking, because while Hubble shows us how vast the universe is, Earth imaging satellites show us just how fragile and interconnected everything is down here. And those images of melting ice sheets, burning forests, rising seas are just as important, just as beautiful, and just as urgent as any picture of a far-off nebula. So the next time someone asks you what would happen if we aimed Hubble at Earth, you can tell them this: it wouldn't work. But the question still matters, because it reminds us that Earth is worth watching, and it reminds us that the tools to do that already exist. We just need to keep using them, one image at a time, one decision at a time. And maybe, one day, we'll learn to treat our own planet with the same awe and care we feel when we look at the stars.